अभी है स्ट्रिंग। ओके, so point B to point D speed will decrease. Point D to point A again speed will decrease, which means from point B to point A there will be retardation, and from point A to point C speed will increase, and from point C to point B again speed will further increase. So in this case, from A to point B, speed is increasing. In this section of the circular motion, we will have acceleration. So we will try to find out tension at different position, especially at point A and at point B, and velocity at point A and at point B. What should be the minimum possible velocity or speed provided to the object at point B? Okay, understood or any doubt in it? Any doubt?
No, sir.
तो इसी में है ये, इससे आगे कंटिन्यू कर रहे। फॉर अपर मोस्ट पॉइंट, uppermost position, which is A in this case. Okay, and if you will look at uppermost position A, there are two forces which are working on the object or the ball which is moving on circular path. Tension in the string towards the center at point A, and mg downward, because both the forces mg and tension are working towards the center. It means centripetal force will be provided by both of them. So for uppermost position A, we can say that both weight mg and tension T are working towards the center. Towards the center in downward direction. In downward direction. So centripetal force will be the sum of these two forces. So tension at point A plus mg, tension at point A plus mg, both these forces will work as centripetal force. Centripetal force F at point A. So centripetal force F at point A. What is the formula of centripetal force? Formula of centripetal force mv square by r. So this will become m va square, va for the point A divided by r, and doesn't matter what is the point. If it is on circular path, radius will be same for each point. So equation is ta plus mg is equals to m va square divided by r. This is the equation. Okay, for minimum possible speed at this point, tension A in the string will be 0. For minimum possible speed, for minimum possible speed at point A to complete the circular motion. To complete the circular motion, tension at point A should be 0. Okay, and you can imagine it, if you will have a ball attached to a string and you will try to rotate it from point B to point A. So as the ball will go from point B to point A, tension will be decreasing. Tension will be maximum possible when you will try to give circular motion to the ball at point B. In that case, tension will be maximum possible, and at point A, tension will be minimum possible. So for minimum possible speed at point A to complete the circular motion, tension at point A will be 0. So if you will make tension A 0, you will have the relation mva square by r is equals to m into g. So m factor will cancel out, yes or no? M factor will cancel out, and finally we will have va square is equals to r into g. So va will be square root r into g. This is the formula you have to remember. Question will be like this: what should be the minimum possible speed at the topmost point or at the uppermost position for any object to complete the circular motion? And in this formula, you can observe mass is not included. Va is equals to square root of r into g. Mass is not there, which means doesn't matter what is the mass of the object. But if it is at topmost point, which is A in this case, the minimum possible speed provided should be square root R into G. This formula also gives us information that VA is directly proportional to square root R, and VA is directly proportional to square root G also. G is not the concern, because at any particular place the value of g will be constant, so we are not taking g seriously. We will take it simply 10 meter per second square or 9.8 meter per second square. But if you will look at the r radius, that is length of the string, so we can clearly observe that greater the length of the string, greater has to be velocity at point A. Smaller the length of string, smaller should be velocity at point A. So if object is at point A, which is topmost point, velocity will be decided according to the length of the string with which this object is connected. Are you getting it or any doubt?
No, sir.
Yes, sir.
आगे चलें.
Yes, sir.
Yes, sir.
Okay. So now we will discuss about lowermost position, that is B. Lowermost position B. Okay. If you will look at it, at lowermost position, weight will be downward mg, and tension at point T will be towards the center, TB. So tension at point B and mg are working on the object at point B, and they are in opposite sense of each other. TB is in upward direction, mg is in downward direction. Okay, yes or no?
Yes, sir.
Okay, so at lowermost position B, at point B, weight mg is downward, weight mg is downward, and tension in the string T is towards the center, towards the center, that is mg, and tension at point B, TB, are in opposite direction to each other, are in opposite direction to each other. Okay, so the relation will be TB minus, because they are in opposite direction, TB minus mg is equals to mvb square divided by r, because in this case TB should be greater than mg. If TB is not greater than mg, circular motion is not possible, because if TB is not greater than mg, it means mg will be greater and the object will be falling downward. Okay, so for object at point B to be in circular motion, it must have some centripetal force, and that centripetal force will be given by TB minus mg. So at lowermost position at point B, TB minus mg is equals to m into VB square divided by r. Now the second condition. Second condition is if object is at point A and the velocity of object at point A is minimum possible, which is given by VA, and when the object is at point B, its speed is VB. So there will be change in kinetic energy. And according to work energy theorem, do you know what is work energy theorem? किसी को याद है वर्क एनर्जी थ्योरम 12th वालों? किसी को याद नहीं है? वेरी गुड. ऑनलाइन स्टूडेंट्स, कुछ याद है वर्क एनर्जी थ्योरम क्या है? Work done equals to change in kinetic energy. So we will apply work energy theorem in this case, which will connect two different velocity together, which is velocity at point A and velocity at point B. So speed at point A is, let's say, VA, and speed at point B is, let's say, VB. The object is going in anti-clockwise sense. And if you will take this ground level, let me call it ground level. This is ground level. Okay, so what will be the distance between these 2 points? This is the center of the circle, so this is r, this is r, which means the object is coming from height h. The object is coming from height h, which will be 2r. So we will apply work energy theorem. According to work energy theorem, work done will be equals to change in kinetic energy of the system. Work done is equals to change in kinetic energy of the system. And in this case, because object is falling from height h. So if initially object is at point A and finally it is coming at point B, doesn't matter by which path it comes, because gravitational force is conservative force, and work done by conservative force does not depend on the path taken by the object. So doesn't matter object will come through the circular path or it will come directly downward from height h, work done will be same. So in this case, according to work energy theorem, work done will be equals to change in potential energy of the system. So work done is change in potential energy of the system, and it will be change in kinetic energy delta K. So change in potential energy is U final minus U initial, or you can simply look at it. If you will look at the change in potential energy, that will be mgh, 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 because object is coming from point A to point B, so it will have some height h which is equals to 2r. And here we have k final minus k initial. So if you will put the data, it will become mg. In place of h, I will have 2r. From the figure, from figure, h is equals to 2r, because this complete is height. So mg into 2r is equals to k final, which is 1 by 2m vb square minus 1 by 2m va square. This is the change in kinetic energy. M factor is present in equation throughout. So cancel M factor. Multiply by 2 the entire equation you will get. If you will multiply 2, it will become 4gr is equals to vb square minus va square, and value of va is equals to square root r into g. We have calculated it, va square root r into g. Substitute it, you will get vb square minus r into g is equals to 4r into g. So vb square will become 4r into g plus r into g. So finally, vb square will be 5 r into g, and vb will be square root of 5 r into g. So this is the minimum possible speed which should be given to the object to complete it vertical circular motion. If you will provide the object speed less than square root 5 rg, the object will not complete the circular path. Remember, it is very important point. If object at point B is given speed less than square root 5 rg, circular motion is not possible, or object will not complete the circular path, will not complete the circular path. It means ये कुछ रास्ते तक जाएगा सर्कुलर आर्क पे और फिर सीधा इस हाइट से नीचे आ जाएगा, तो कंप्लीट सर्कल नहीं बना पाएगा. If we have speed equals to square root 5 rg, circular motion is possible. If we have speed at point B greater than 5 rg with square root, again circular motion is possible. If you will look at the relation between VB and VA, so VB minimum is equals to root 5 into root rg, and root rg is the minimum possible speed at point A. So this will become root 5 times v point A minimum. It means lower most point पर जो speed होगा वो top most point से root 5 times ज्यादा होगा, and VB will always be greater than VA. Understood or any doubt? Understood or any doubt?
Yes, sir.
If we have the value of VB, we can find out tension in the string at point B. Remember, tension in the string at point A is already zero. When we have done the derivation for point A, we have taken tension at point A equals to zero. So for minimum possible speed, tension at point A will be zero. Now I am interested in tension at point B if the speed provided at point B to the object is minimum possible to complete the circular motion. So we have tension at B minus mg is equals to m vb square by r. Substitute the value of VB. So M VB is square root 5 RG, and when you will square it, you will have 5 times RG divided by R. R factor will cancel out. So TB minus MG is 5 times mg. So tension in the string at point B is 5 mg plus mg, which will give 6 times mg. So tension at point B is 6 times mg, which is a standard result. If you are having a vertical circular motion, tension at the lowermost point will always be 6 times weight of the object. Mg is weight of the object. So tension at lowermost point is equals to 6 times weight of the object. Understood or any doubt?
Yes, sir.
Next condition. Next condition is position when the string is horizontal, which means the string is at point C and D in the figure. At point C and D. This is point C, this is point D. So how you will calculate velocity at point C or tension at point C? Again, we can use work energy theorem. If you want to find out what is the velocity at point C if object is coming from point A, let us consider that C is at ground level and then apply the work energy theorem. You will get velocity at point C minimum possible. Similarly at point D minimum possible. At point C and at point D velocity will be same because motion is symmetric. Air resistance is not present. So whatever will be at point C, the same will be at point D. And tension at point C will be the only responsible force for centripetal force because mg is working downward. So mg is not responsible in this case for the centripetal force. So let us discuss about point C and point D. Next case, when the string is horizontal, which means at point C and D. Let's discuss about point C. This is the circular path. This is center, and let me call it ground level. This is point C. So point C is at ground level. And this is point A. Point is at the topmost point. Speed at point A is VA. And speed at point C is VC. Let's say this is speed at point C, VC. And the only responsible force in this case for centripetal is tension in the string TC, because mg will be working downward. So the interesting point in this situation is mg is not responsible for centripetal force. mg is not responsible for centripetal force. Okay. So TC is the only force for centripetal force. Tension is equals to M, velocity at point C square by R. So if you want to find out tension at point C, it will be TC is equals to MVC square by R. And remember, tension at point A is 0. So TC minus TA will be same thing. You can also write it as TC minus TA. TA is 0, so it doesn't matter. TC minus TA is same as TC. Now we will try to find out velocity, because if I have velocity, I can find out tension easily. And for that, again, I will use work energy theorem for point A and point C. What is the height, or what is the difference of height between point A and point C? I have taken point C at ground level. Similarly, it will be true for point D also in this case. Okay. And let's say tension at point D will be TD. So both the points, whether it is point C or point D, are on the ground level, and the object is coming from point A, which is at certain height. And in this case, height H will become equals to radius R. So apply the work energy theorem. According to work energy theorem, work done to come from point A to point C, or work done by the gravitational force to take object from point A to point C, will be equals to change in its kinetic energy. And let me tell it again, gravitational force is conservative force. So path of the object doesn't matter. Doesn't matter object is coming on the circular arc, or object is coming directly downward in vertical direction. Doesn't matter. In both the cases, work done between point A and point C by the gravitational force will be exactly same. And that will be equals to change in potential energy. And if you will look change in potential energy, it will be equals to mgh, which is equals to k final minus k initial. K final minus k initial. So mg height will be r is equals to kc 1 by 2 m vc square minus 1 by 2 m va square. Again, m factor will cancel out. Multiply the entire equation by 2. This will become 2rg is equals to vc square minus va square. Again, va is what? va is square root rg. So if you will substitute the value of va, equation will become vc square minus rg is equals to 2rg. So vc square will become 3rg. So vc is equals to square root 3rg, which means speed at point C is root 3rg. Similarly, Similarly, speed at point D is also square root 3 rg. Okay. Now look at tension T. Tension T is directly mvc square by r. So we can find out tension at point C. Tension C is m vc square by r. Substitute the value m. vc square will become 3rg divided by r. R factor will cancel out. So tension at point C is 3 times mg. Similarly, tension at point D will also be 3 mg. Are you getting it or any doubt?
Yes, sir.
Okay, at any arbitrary position, if you want to find out the velocity and tension, we will use two different concepts. First one, we will use uh, centripetal force, an equation which involves centripetal force using tension and component of weight, mg. And another equation or another relation, if it is possible due to symmetry, will be work energy theorem or law of conservation of energy. So complete summary of the topic is in the given figure. Let's say this is the circular path on which object is moving. This is point A, this is point B, this is point C, this is point D. At point A, everything at point A. क्या हुआ? At point A, everything about point A. At point A, VA minimum will be square root RG. At point A, TA will be 0. At point B, VB minimum will be square root 5 RG. TB will be 6 times mg. At point C, VC minimum will be square root 3 RG. पॉइंट मैंने गलत कर दिए, ये डी पॉइंट था और ये हमारा सी पॉइंट था. दिस इज पॉइंट सी, दिस इज पॉइंट डी. So this is VD minimum and tension at point D is 3 mg. Similarly at point C, VC minimum is root 3 Rg and TC is 3 mg. Understood or any doubt? Any doubt?
No, sir.
क्वेश्चन करें इससे रिलेटेड. अब क्वेश्चन स्ट्रेट फॉरवर्ड आते हैं और हर एग्जाम में आते हैं. सीईटी, नीट, जेई बनता रहता क्वेश्चन. क्वेश्चन नंबर 1. An object of mass 0.5 kg is moving on a circular path. Is moving on a circular path in vertical plane. In vertical plane. Resistive force are not present in system. Are not present in the system if radius of or radius ही ले लेते हैं पहले. If radius of circular path is 4 meter, find first part minimum speed at the lowermost point for vertical circular motion. Second, tension at lowermost point. At lowermost point in case first. Third, minimum possible speed at uppermost point. Uppermost point. Fourth, tension in case third. Number 5, minimum possible speed when the string is horizontal. Number 6, tension in the string for case 5. पूरा का पूरा ये एक ही क्वेश्चन में आ गया. जितना भी कॉन्सेप्ट है सब ये सिंप्लीफाई करना है. ए नालायको, इधर सोने आते क्या तुम लोग? सोना है तो बाहर जाओ और वहां सो, मेरी क्लास में मत सो. वो देखो, फिर आएंगे बोल देंगे कि सर आप लोग ध्यान नहीं देते. ये नहीं बोलेंगे कि बच्चे ऐसे हैं, टीचर को ही बोलेंगे. Question is, we have an object of mass 0.5 kg which is moving on circular path in vertical plane, and we consider that no resistive force is present, means the motion is completely under gravity. Radius of circular path is 4 meter and we have to extract every information possible. नहीं है, कुछ नहीं है, only gravity है. Radius is 4 meter. Mass of the object is 0.5 kg. First part is minimum speed at lowermost point. So we at lowermost point minimum possible to complete the vertical circular motion. We have direct result for it. क्या result है बोलो? लोअर मोस्ट पॉइंट के लिए स्पीड मिनिमम पॉसिबल कितनी आई, अभी हमने एक्सट्रैक्ट किया था, ये रहा यहाँ सारा रिजल्ट। सो इट इज स्क्वायर रूट 5 rg, स्क्वायर रूट 5 rg, स्क्वायर रूट 5 r इज 4, g लेट से 10 है, तो दिस विल बिकम स्क्वायर रूट 200, which means 10 root 2 meter per second. And if you will find out tension at lowermost point, for tension we have formula 6 times mg, 6 times m into g. So this is 6 into m. M is 0.5 into g. G is 10. So this will become 6 into 5. That is 30. What is the SI unit of tension? SI unit of tension? Newton. Next, third point, we have to find minimum possible speed at uppermost point. So V at uppermost point, minimum, whatever be the name of this point, A, B, C, P, Q, R, doesn't matter. So what is the formula for uppermost point? Square root RG. So square root R is 4 into G is 10. So this will become 2 root 10 meter per second. Tension at uppermost point in the case of minimum velocity. So tension at uppermost point in the case of minimum velocity is 0. uppermost point पर टेंशन कितना आता, 0 आता मिनिमम वेलोसिटी के केस में. Then we have number 5. Number 5 is minimum possible speed when the string is horizontal. So tension T, sorry, speed V. Speed V if string is horizontal. Speed V in this case is given by root 3 rg. Yes or no? String will be horizontal in case of C and D. So minimum possible speed is square root 3 rg. So V minimum in this case is square root 3 rg. Square root 3. R is 4. G is 10. So this will become how much? 2 root 30. Which is 2 multiply. Root 30 का वैल्यू कोई बता पाएगा कितना होता? हाँ 5.4 क्या 5.5 तो वैसे ही आ जा रहा है. 5.6 कर देता हूँ. V minimum. So this will become 12, 11.2 meter per second. Tension in this case. So tension in this case is given by tension if string is horizontal. Is given by 3 times mg. So tension T 3 into m 0.5 into g 10. So T is 3 into 5, that is 15 Newton. Understood or any doubt?
Yes, sir.
Question is, next question. An object having speed having minimum possible speed. Minimum having minimum possible speed 20 meter per second at lowermost point in vertical circular motion. What will be the length of string? What will be the length of string? Or length of string means or radius of the circular path. Radius of the circular path taken by the object. Taken by the object in given vertical circular motion. Okay. So in this case, an object is having minimum possible speed 20 meter per second at lowermost point. So we have to find out the length of string. So V lowermost point minimum is 20 meter per second. For the lowermost point, the minimum speed is given by the formula square root 5 RG. So square root 5 RG is equals to 20. Square on both sides. This will become 5 into R into G is equals to 20 into 20. Yes. So 10 to the 20. 5 for the 20. So required radius will be 2 into 4, 8. And unit will be meter. Understood or any doubt?
No, sir.
आगे चले भाई. Question is, an object is moving or an object is in vertical circular motion with radius, let's say radius is 10 meter. An object is in vertical circular motion with radius 10 meter. Okay. Mass of the object is let's say 5 kg or let's say 2 kg. Mass of the object is 2 kg. If the speed of the object, at uppermost point is 15 meter per second. If the speed of the object at uppermost point is 15 meter per second, find the tension in the string, find the tension in the string at uppermost point. बोलो क्या आंसर आएगा?
0 sir.
Yes, what is the answer?
0.
0. कैसे पता चला 0 आएगा?
सर अपर मोस्ट पॉइंट पे टेंशन 0 रहता है.
अपर मोस्ट पॉइंट पे टेंशन 0 रहता है, बट मैंने ऑलवेज वर्ड इस्तेमाल नहीं किया पूरे डिस्कशन में, या मैंने बोला है ऐसा दैट टेंशन एट अपर मोस्ट पॉइंट इज 0 ऑलवेज? बोलो. पूरे डिस्कशन में ऑलवेज वर्ड मैंने एक भी बार इस्तेमाल नहीं किया, which means in all the cases tension at uppermost point will be 0 is not true. In some cases, or let's say in a special case, tension at the uppermost point will be 0, and that special case is if object at the uppermost point will have minimum possible speed. तो इस केस में अपरमोस्ट पॉइंट पर टेंशन 0 होगा कि नहीं, दैट विल बी डिसाइडेड बाय द मिनिमम पॉसिबल स्पीड. तो हम पहले मिनिमम पॉसिबल स्पीड निकालेंगे. सॉल्यूशन: v at uppermost point minimum is given by root r into g. In this case, r is how much? R is 10. So 10 into g is also 10. So minimum possible speed is 10 meter per second. If object has 10 meter per second at the uppermost point, in that case, we will say tension at uppermost point is 0. But I have clearly given you the speed at uppermost point. If the speed of the object at uppermost point is 15 meter per second, which is greater than the minimum possible speed, which means it will not have 0 tension at the uppermost point. So we will write it as since speed v is 15 meter per second, which is greater than speed uppermost point minimum. So tension at uppermost point is not equals to 0. So it will be some finite value, and I am interested in that value. So we will use the relation, and the relation is, if you will look at the diagram, in this case, when the object will be at uppermost point, mg and tension in the string will be working in the same direction, and that will be responsible for mv square by r, that is centripetal force. So I will write it as tension at uppermost point plus m into g is responsible for mv square by r. Remember, in this case, speed v is not the minimum possible speed. So if it were minimum possible speed, tension will come 0. And if it is not minimum possible, it is some different value. When you will substitute that value into the formula, you will get the value of tension. So substitute the data. So tension at uppermost point will be mv square by r minus m into g. Put the data. M is 2 kg. V at uppermost point is given to us 15 meter per second. So 15 into 15 divided by radius 10 minus m 2 into 10. So this will become 15 into 2, 30 into 15 by 10 minus 20. Yes or no? So tension at uppermost point, which is not 0 in this case, is 45 minus 20. Yes or no? So tension at uppermost point will be 25. Okay. Yes, Newton. Are you getting it? Are you getting it? So let me tell it again. All these relations are in a special case. If we have minimum possible speed at point B, only then tension will be 6 mg. If speed is greater than the minimum possible speed, tension will be greater than 6 mg. So tension at all point will vary according to the velocity of the object. And if it is not minimum, it will be greater than minimum or less than minimum. If it is less than minimum possible, circular motion is not going to happen. If it is greater than minimum possible, circular motion will take place, but tension will change its value accordingly. Okay. So remember, tension at point A is not 0 always. Tension at point A or tension at uppermost point will be 0 if and only if object has minimum possible speed at point A, which is square root rg. That is also true for other points in this motion. Understood or any doubt? बोलो, समझा या कोई डाउट है?
समझा सर.
No, sir.
नहीं समझा?
समझा सर.
ठीक. Next concept is, if the object is not connected with a string but with a rod, so vertical circular motion of a mass tied to a rod like this. There is a rod, not a string. Okay. And a mass is connected with it. And this rod is rotating the mass in vertical circular motion. So we have to find out minimum possible speed at lowermost point and also tension. Okay. लोअर मोस्ट पॉइंट का मीनिंग यहां है, अगर वर्टिकल सर्कुलर मोशन है ऐसे, एक पिक पॉइंट होगा ऊपर और एक सबसे नीचे वाला पॉइंट होगा, तो दिस इज लोअर मोस्ट, दिस इज अपर मोस्ट, और बीच की कहानी चलती रहेगी. ओके. Important point is difference between string and rod. The basic difference is, for string it will need some tension at all the points, but in case of rod, ऐसा लिखेंगे, in case of string, in case of string, in case of string, some speed which is V minimum is necessary for the object at uppermost point but in case of road speed at uppermost point may also be zero समझा क्या? स्ट्रिंग और रोड का जो बेसिक डिफरेंस है वो ये कि टॉप मोस्ट पॉइंट पर रोड अगर है तो जीरो वेलोसिटी भी हो सकता है ऑब्जेक्ट का, बट अगर स्ट्रिंग है तो जीरो वेलोसिटी नहीं हो सकता ऑब्जेक्ट का कुछ ना कुछ क्या बोलते हैं स्पीड जरूर होगा एट टॉप मोस्ट पॉइंट इन केस ऑफ स्ट्रिंग। अगर कुछ स्पीड नहीं रहेगा स्ट्रिंग के पास तो स्ट्रिंग में स्लैकिंग होगी और सर्कुलर मोशन कंप्लीट नहीं हो पाएगा। दैट इज द रीजन वी हैव कैलकुलेटेड मिनिमम पॉसिबल स्पीड एट द टॉप मोस्ट पॉइंट। इतनी तो चाहिए ही चाहिए रूट आर जी, इससे ज्यादा हो तो कोई प्रॉब्लम नहीं, बट इससे कम हुआ तो मसला है। और जीरो नहीं हो सकता। जीरो क्यों नहीं हो सकता यहां से जज करेंगे। देखो कहां गया, ये रहा। देखो जीरो क्यों नहीं हो सकता। इस फिगर में हमने इक्वेशन बनाया है टी ए प्लस एम जी इज इक्वल्स टू एम वी ए स्क्वायर बाय आर। अगर मैं ऐसा कंसीडर करता हूं कि लेट से एट टॉप मोस्ट पॉइंट जीरो इज पॉसिबल, तो वी ए का वैल्यू जीरो होगा। एंड व्हेन यू विल टेक वी ए इक्वल्स टू जीरो, टेंशन टी ए प्लस एम जी विल बिकम जीरो। टेंशन टी ए विल बी निगेटिव ऑफ एम जी। टेंशन टी ए निगेटिव ऑफ एम जी मीन्स टेंशन टी एंड एम जी will work in opposite direction. But if you will look in the situation, they are working in the same direction, which means it is not possible. So, in vertical circular motion, in the case of string, object cannot have zero velocity or zero speed at topmost point. It will definitely have some minimum possible speed, that is root rg. बट मेटेलिक रोड जो है उसके केस में हम बोले कि ये जीरो भी हो सकता है। इट में ऑल्सो बी जीरो इन द केस ऑफ रोड। और उसके बाद दो फॉर्मूले याद रखने अब आपने। इन केस ऑफ रोड है ये थर्ड पॉइंट, वी एट लोअर मोस्ट पॉइंट मिनिमम पॉसिबल इज स्क्वायर रूट 4rg। एक यूनिट कम है, उसमें 5rg था, इसमें 4rg है। 2 √rg, उसमें √5 था, इसमें डबल है। एंड इसके बाद दूसरा जो फॉर्मूला है दैट इज टी एट लोअर मोस्ट पॉइंट जो मैक्सिमम पॉसिबल होगा माइनस टी एट अपर मोस्ट पॉइंट। टी एट अपर मोस्ट पॉइंट मे बी जीरो इन दिस केस एंड इट विल इक्वल्स टू 6 टाइम्स m इंटू जी। समझ में आ गई बात या कोई डाउट है? बोल दो यस और नो। क्वेश्चन स्ट्रेट फॉरवर्ड होगा। इफ एन ऑब्जेक्ट इज अटैच्ड, लिख ही देता हूं इसके ऊपर क्वेश्चन कैसा बनेगा। क्वेश्चन इज इफ एन ऑब्जेक्ट is in vertical circular motion by a rod of length 2 meter, by a rod of length 2 meter, find minimum possible speed, minimum possible speed, find minimum possible speed at lowermost point. तो डायरेक्ट फॉर्मूला है हमारे पास, v at lowermost point minimum possible is square root 4 rg, which is 2 root rg. So this will become 2 into root. R is 2, G is 10. Yes or no? So this is 2 root. 2 into 2 into 5, which will become 4 root 5 meter per second. Understood or any doubt?
Understood, sir.
एक ये लास्ट कॉन्सेप्ट रह गया इस टॉपिक का, ये भी कंप्लीट कर ही लेते हैं। सिंपल सा है, स्फीयर ऑफ डेथ। क्या कंडीशन है भाई? दिस इज अ पॉपुलर शो इन अ सर्कस। ड्यूरिंग दिस, two-wheeler rider undergo rounds inside a hollow sphere, starting with small horizontal circles. They eventually perform revolutions along vertical circles. The dynamics of this vertical circular motion is the same as that of the point mass tied to the string, except that the force due to tension T is replaced by normal reaction N. If you have seen this, so try to visualize. तुमने देखा क्या ये? मैंने तो ना देखा। बट कंडीशन ये है कि अगर इसके ऊपर ये चलता है तो किस तरीके से मेंटेन रहेगा। और क्योंकि स्ट्रिंग बंधा हुआ नहीं है, बाइक है, बाइक चल रही है इसके ऊपर। समझ में आ रहा है कि कैसे बोल रहा हूं? एक बड़ा स्पीयर है, उसके ऊपर बाइक है, हाँ, और ये घूम रहा है स्पीयर। तो ऊपर वाले बंदे को इस तरीके से मेंटेन रखना खुद को कि चलता रहे। हाँ, ठीक है, गिरे ना, मतलब मेन पॉइंट ये है। तो अगर ये घूम रहा है सर्कुलर पाथ पे, इसका मतलब जो ऑब्जेक्ट है वहां उसका मोशन भी सर्कुलर होगा, और अगर वो सर्कुलर होगा तो सेंट्रीपिटल फोर्स की जरूरत पड़ेगी। तो मेन टारगेट हमारा ये है बस कि सेंट्रीपिटल फोर्स आएगा कहां से। तो ये दिखाया इसने, यहां अगर ऑब्जेक्ट है और ये सेंटर है इसका, ये हो गया जी सेंटर, ये रेडियस बन जाएगी, जैसे नो। और जब ये सरफेस के ऊपर होगा, in that case the surface will provide some normal reaction N, so normal reaction N, and mass of the object is downward mg. Okay, so centripetal force कहाँ होगा? Towards the center, which means mg should be greater than, if mg is greater than n, mg minus n will work as centripetal force. Okay, so for the safe vertical circular motion, mg should be greater than normal reaction. So mg minus n will give mv square by r. mg minus n will give mv square by r. Okay. इंप्रेसिव. अब देखो क्या बोल रहा. अब ये बोल रहा है कि स्पीड जितनी ज्यादा होगी, स्पीड जितनी ज्यादा होगी, नॉर्मल रिएक्शन उतना कम बनेगा. कैसे एक्सप्लेन कर सकता है कोई मुझे ये बात? सर्कुलर आर्क है एंड उसके ऊपर एक ऑब्जेक्ट है, और ये जो सर्कुलर आर्क है ये घूम रहा है अगर, तो कंटिन्यूअसली कॉन्टैक्ट बिटवीन द स्फीयर एंड ऑब्जेक्ट विल चेंज. ये सुनो, मान लिया पहले पॉइंट ए पे था कांटेक्ट, अभी अगर ये घूम रहा है तो पॉइंट ए वहां थोड़ा ना रहेगा, सम न्यू पॉइंट विल कम, बी आएगा, सी आएगा, ऐसे. यस और नो? और जो नॉर्मल रिएक्शन है दैट इज अ कांटेक्ट फोर्स, विच मींस कांटेक्ट अगर अच्छे से होगा तो नॉर्मल रिएक्शन अच्छे से आएगा, नहीं तो नहीं आ पाएगा. तो अगर पॉइंट कंटिन्यूअसली चेंज हो रहा है तो नॉर्मल रिएक्शन पे फर्क पड़ेगा, बिकॉज इट विल डिपेंड ऑन द टाइम ऑफ कांटेक्ट, कितने टाइम के लिए कांटेक्ट हो पाया. और अगर ये स्पीड बढ़ाएगा अपनी, तो ए पॉइंट का कांटेक्ट बहुत ज्यादा टाइम के लिए ऑब्जेक्ट के साथ नहीं हो पाएगा, विच मींस जैसे जैसे स्पीड बढ़ेगी कांटेक्ट का टाइम घटेगा किसी भी पॉइंट का, ए का, बी का, सी का, सबके साथ. और इस वजह से क्या होगा, जो नॉर्मल रिएक्शन है वो क्या होगा, डिक्रीज होता जाएगा. तो एक लिमिटिंग केस में नॉर्मल रिएक्शन क्या होगा हमारा, 0. तो लिखा हुआ है फॉर जस्ट maintaining the contact, maintaining the contact, n कितना हो जाएगा इस केस में, 0. तो mg minus 0 is mv square by r. So mg is equals to mv square by r. m से m factor cancel, so v square is rg. So v will be square root rg, and we will call it maximum possible speed allowed to do the stunt. क्यों? क्योंकि ये कब आई स्पीड, जब हमने n को 0 कर दिया. n को 0 करने का मतलब है कि जस्ट कांटेक्ट हो रहा है बस. अगर इससे ज्यादा हुआ, इससे ज्यादा अगर हुआ, कांटेक्ट खत्म हो जाएगा. कांटेक्ट खत्म होगा तो जो बंदा है रुका हुआ वहां वो गिर जाएगा. समझ में आ रही बात? को परफॉर्म करने के लिए मैक्सिमम पॉसिबल स्पीड अंडरस्टूड, और एनी डाउट? बाकी अगले लेक्चर में करेंगे. एक ये न्यूमेरिकल बचा हुआ है आपका, और अगला कॉन्सेप्ट अब स्टार्ट कर सकते हो. ठीक है, कल तो शायद मेरा लेक्चर नहीं होगा, तो बता देना सर को जहां तक हुआ है. ये पीडीएफ लगेगा क्या वापस? ऑनलाइन वालों ये सेंड करना है क्या?
Yes, sir.
यस सर.
जूम पे सेंड कर दूं क्या?
हाँ सर, कर दो.
यस सर.